Hey guys, welcome back to my channel. In this tutorial we will look at this integral. How do you solve this integral? This is an MIT integration B question of 2024 regular season quarterfinals. So please subscribe to my channel for more of these integrals. So we can start off by dividing the numerator and the denominator of this integral by 2e to the x. This is the numerator, and the denominator you divide by 2e to the x as well to maintain equality, plus 2 squared all over 2e to the x. Then the x and this one can be simplified into the numerator stays the same, x squared over 2e to the x divided by the denominator is 4e to the 2x plus x squared plus 2x plus 2 squared all over. This can be written as the square root of 4e to the 2x dx. And I can now put everything in the square root, x squared over 2e to the x divided by the square root of, because everything is now in the square root, I can put them in. So this one divided by this one is going to be 1, right? So that is going to be 1 plus this one divided by, no, this one divided by this in a square root, that is going to be x squared plus 2x plus 2 all over 2e to the x all squared, like this, dx. So this is how our integral can be simplified after dividing by 2e to the x. So we can now really do a u sub here. We can let u to be equal to x squared plus 2x plus 2 all over 2e to the x. That is this giant one in the parentheses. So we can now differentiate du dx. We can use the quotient rule here. This is u, this is v. So that is v du dx. So you keep 2e to the x constant, and you differentiate this, which is differentiating this one is going to be 2x plus 2 minus, you keep this one constant, plus 2x plus 2, then you differentiate this, that is 2e to the x divided by 2e to the x all squared, like this. So you can multiply out, this is 4xe to the x, 4xe to the x plus 4e to the x minus 2x squared e to the x minus 4x e to the x minus 4e to the x. That is opening up everything. So this one squared is going to be 4e to the 2x. This is du dx. So du dx is going to be equal to what? This one will cancel up with this, and this one will also cancel with this. And that is going to be negative 2x squared e to the x divided by 4e to the 2x. And this one really simplifies to negative x squared over 2e to the x. This is how this can be simplified. So in the end, du is going to be negative x squared over 2e to the x dx. Now we can now go back to our integral. We look at this one, x squared over 2e to the x dx. We can replace that with du, right? But what I'm going to do here is that I'm going to multiply this one by negative, since this is negative. But in order to nullify the negative, I can multiply the integral by negative 1 as well. So that is how we can do this manipulation. And we can now switch back to our white pen. Why not? This is now negative the integral. The whole of this now, this is du. So that is going to be du all over the square root of 1 plus the whole of this was u. So that is going to be u squared, like that. So our integral now reduces to the negative integral of 1 all over the square root of 1 plus u squared du. So this one is something familiar. We know this. This is the sine hyperbolic inverse function. So this one is the sine hyperbolic inverse function, like the sine hyperbolic inverse function of u. So that is how to integrate this. But what is the value of u? U was this x squared plus 2x plus 2 over 2e to the x. So this is now equal to negative sine hyperbolic inverse function of x squared plus 2x plus 2 all over 2e to the x plus the constant of integration. And this one is equal to our integral. That is the integral of x squared over the square root of 4e to the 2x plus x squared plus 2x plus 2 all squared dx. This is the value of our beautiful MIT integration B question. So if you find this helpful, please subscribe to my channel for more of this content. I thank you so much for watching this video, and I will see you in the next one. Bye bye.